Hello guys, welcome to another video in the series of coding. Today we are going to do the problem which is called minimum x XOR a. Let's try to understand what is the problem. You are given two integers a and b. The task is to find an integer x such that x XOR a is minimum and the count of set bit in x is equal to the count of set bits in b. Let's try to understand first of all what the problem is saying. So we are given two numbers. Okay, let's take an example. Let us say a is equal to 9 and let us say b is equal to 11. So let's break down the problem step by step. We have to find a number x and we have to return that as our answer. Now what is x? X should have the same number of bits set as b. Same number of bits set as b. This is the problem. But x should also have x XOR a should be minimum. So x should satisfy two conditions. First condition is it should have the same number of bits set as b. Second condition is our x, if we do XOR with a, it should be the minimum possible value. Now let's see how we can satisfy these two conditions. Let's discuss the condition one by one. Let's go to the first condition. First condition is very simple. X should have same number of bits as b. So what is our b? b is 11, right? Let's find out the number of bits in b. b is 11. Let's try to represent 11. So let me write the binary representation. This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Now what is 11? 11 is 2 power 3 plus 2 power 1 plus 2 power 0, right? So here I am going to place 1, 1, 1 and here it will be 0. So corresponding to 2 power 3, 2 power 1 and 2 power 0, we can give the values as 1. So 8 plus 2 plus 1 will be equal to 11, right? So now what is our b? b is 1011. Simplistically speaking, b is just in binary representation 1011. How many bits are set in b? So b has 3 bits set, right? So b has 3 bits set. This should be the same number of bits set in x. So now let's come back to our first condition. So first condition is x should have same number of bits set as b, means x should also have 3 bits set, right? So x should have 3 bits set. This is the first condition. Now let's come to the second condition. It is given that x XOR a should be minimum. Let's try to see how we can satisfy the second condition while satisfying the first condition also. Okay. So what is a? a is 9. Let's write the binary representation of 9. 2 power 0, 2 power 1, 2 power 2, 2 power 3. 9 is nothing but 8 plus 1, right? So 2 power 3 is 8 and 2 power 0 is 1. So this is 9. So what is our second condition? Whatever x we are taking, which is supposed to have 3 bits set, we should also take care that if you do x XOR with a, right? Let me erase this first of all. So if you do XOR of x with a, this is our a and this is our x. If you do XOR of these two numbers, you should get the least or minimum possible value whichever is possible. You should get the minimum possible value here. Okay. Now first let's see what is the XOR operator. XOR operator is very simple. XOR operator means whenever you have different bits, for example 1 and 0 are different, right? You get the output as 1. Whenever you have same bits, for example 0 and 0 or 1 and 1, you get the output as 0. If you have the same bits in the input, okay, if you have the same bits in the input, then you are going to get the output as 0. If you have the different bits in the input, 1 and 0 are two different bits, then you are going to get a output as 1. So the XOR operator is very simple. For different bits in the input, you are going to get the output as 1. Okay, XOR operator is this. Now we know what is XOR operator. Now let's try to see how we can get the minimum possible value. First of all, what is the minimum possible? Minimum we are trying to achieve or we are trying to aim, we get all zeros, right? This will be the least or minimum possible value. If we are able to get this is awesome because this is the minimum possible number at all. So we know that we have to try to achieve the minimum possible value. Okay. So how will we achieve a 0 here? Okay. So we have to XOR a and x and we have to try to achieve the minimum possible value. Let's think about it. If we have to get a 0 here in a you can see that this bit is set, right? So what should come here says that 1 XOR something is going to give you 0. So it should be 1, right? Because 1 XOR 1 will give you 0. So here if you have a bit set in a, if you go and set that bit in x also, then if a bit is set in A, okay, bit is set in A and the bit will be set in X, both the bits, if you XOR, you will get 0, and 0 is the minimum possible value, right? You have only two choices, 0 or 1, so minimum is 0, right? If you get 0, it is awesome, it is amazing. We are trying to aim for 0. So wherever the bit is set in A, we are going to set the bit in X also. Okay, now one very interesting question I want to ask you is, we can only set 3 bits, right? So, okay, here we have lot of bits to set. We can set 3 bits only. We can set 3 bits, but what if, okay, it's not always possible that we have lot of bits to set. Suppose, okay, suppose here we had only 1 bit to set. Suppose here B was 1, okay, and you had only 1 bit to set. So where are you going to set the bit? Are you going to set the bit here such that 1 XOR 1 will be 0 here, or are you going to set the bit in X here such that 1 XOR 1 will be 0? I have to ask this question. Okay, so this is a very interesting question. If you have, let's take the example when B is equal to 1. In that case, you only have 1 bit to set, and this is your A. Where are you going to set the bit, right? So let's discuss that. If you set the bit here, right, so 1 XOR 1 will give you 0, okay, and this will be your output. What will be your output? So all other places in X, I am going to leave it as 0, and what will be my XOR? 1 XOR 1 will be 0. 0 XOR 0 will be 0. 0 XOR 0 will be 0. 1 XOR 0 will be 1. Okay. So if I am deciding to set the bit here, I have only 1 bit to set. I am considering the example when I have only 1 bit to set to try to understand one important point, that in case we have scarcity of bits, where are we going to set the bit? So if we set the bit at the highest place value, right? If we set this is highest, okay, this is high to low, we are moving like this from high value to low value. So if we are going to set the bit at the first place, we are going to get the output as this. What is the XOR? If we, let me write it, let me erase all this and let me write. So we had an option, if we have to only set 1 bit, okay, in that case, if we set the bit at the highest possible value, then in that case the output that we get here, the output here was this one, right? So this is our output, this is nothing but 1, okay, you get the output as 1. If you are decided to set the bit here in X, you can set only 1 bit in X. If you decide to set that bit here instead of this place, then in this case this will be your X, right? The last bit alone will be set and remaining all will be 0. What will be the output in that case? 1 XOR 0 will give you 1, 0 XOR 0 will give you 0, 0 XOR 0 will give you 0, 1 XOR 1 will give you 0. Okay, so in that case your output will be 1. Okay, 1 0 0 0. Let's note this number, let's note the output that we just got. So what if I set the bit in the lowest possible value, then the output I get is 1 0 0 0. We just saw, right? So we had two options. In case we are setting the bit here, we are getting this as answer. In case we are setting the bit here in X, then we are getting this as answer. Okay, now which is better? What is the value of this? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. This is 8, right? This number is 8. So compared to 1 and 8, which is the minimum possible answer? 1 is the minimum possible answer, right? This is the minimum. So where should you set the bit? Whenever you have a choice to set a bit, right? In case you have scarcity of bits and you have a choice to set bits, you should always set at the highest possible value, so that 1 XOR 1 will give you 0 at the highest possible place value. If you get 0 here, it is awesome, right? Because you have to try to make the number as small as possible, and if you have to try to make the number small as possible, in the high values you should set a 0. Okay, so this is our logic. So we should set the bit, in case we have scarcity of bits, we should always set the bit at the highest possible place digit. So we are moving from right to left, right? So first we will start looking for bit set in the right, and whenever we see bit as 1, we are going to make it 1 in our X also. Okay, so now let's come back to our example. Let's discuss this example. In this case, when we have 3 bits to set, right? In this case, what we are going to do, it is amazing, right? We have 3 bits to set. So I will see a bit set here. I will make this also as 1. I will move forward. I will see a bit set here. I will make this also as 1. Okay. So this will become my X. So when this becomes my X, I am getting the 1 XOR 1 will be 0. This will be 0, this will be 0, 1 XOR 1 will be 0 again. So this will be the possible value. But we have to set 3 bits, right? You have to set 3 bits, in this case you have extra bits. Okay, in this case you have extra bits. Your A has only 2 bits. you have set that 2 bits as 1, but you have to set 3 bits. If for example you have such a condition in which you have to set 3 bits in x, then what will you do? Then you have to set one more bit in x, right? So you have to do something. So where will you set that bit? Now again an interesting question. Okay, so where will you set that bit? So we will set that bit, we have to try to make this as minimum, right? So we have to set the bit somewhere. So we'll try to set it now in the lowest possible value, because see, let's set this bit in x here. X should have 3 bits set, so I'm going to set 3 bits here. So that 0 and 1 will give me here, it will give me 1. This is the minimum possible XOR, and this will be my answer. Why did I set the remaining bit here? Okay, let's consider the case. Why did I set the bit here? Because see, 2 bits are already set, right? 2 bits are set, that's it. Now the third remaining bit where I should set, that was my question. What if I had set the third remaining bit here? Then in that case, here I would have got 1 in the output. 0 and 1, if you do XOR, you will get 1 here, right? So this answer is greater than this answer. If, okay, so let me try to explain it properly. See, I had option to set the remaining extra bit either here or here, right? So if I am setting the remaining extra bit here, in that case I am getting the output as this, right? Now this output is greater, right? What is this output? This 2 power 0, 2 power 1, 2 power 2. This output is 4. Okay, the answer of this XOR value is 4 if I set the extra bit here. But if I set the extra bit instead of here, if I set the extra bit here, then what is my answer? My answer is just 2, right? The XOR value which I am finally returning is 2. 2 is minimum. So when I have remaining leftover bits after setting all the bits same as A, then in that case what I am going to do? I am going to set it at the minimum possible value, because I get least possible answer if you try to set from the left side. So this is the logic. Okay, now let's try to code this, then it will be much more clearer, hopefully. So first step is count the number of bits set in x. Okay, so what I'm going to do, we have to count the number of bits set in x. So let's declare a variable. So it is very simple, right? Let's count the bits set in x. So I'm going to take a variable b, which I'm going to make the same as b. And how to count the bits set in b? It's very simple. How to count a bit set in any given number? So just take the given number, keep dividing it by 2, right? And you check the remainder. Okay, for example, how to count the bit set? So you just take b mod 2, okay, and just if b mod 2 is equal to 1, right? If the last digit is 1, then you can just count that bit. So this is the simple logic to just find out how many bits are there in a given number. Okay, let me take one example, then it will be much more clearer. Let's discuss our example. For example, b is equal to 11, right? So what is 11? This is the binary representation of 11. Okay, so I am taking this. So this is our b. We have 1011. So what I am doing, so I have to count the number of bits set in b, and my answer should be equal to 3, right? So in this way, I should save the answer as 3. So how do I find the answer? So what I'm doing, I'm taking the last value. The last value is 1, because I'm doing b mod 2. It is a b mod 2 is going to check the last value, the last remainder. If it is 1, right, here it will count 1. So here if I do b mod 2, I am getting the remainder is 1, because the last digit is 1, right? So that's why I'm counting 1 bit. So in this case, the number of bits are 1 when I take the last digit. Now I divide it by 2. When I divide the number by 2, I have this number remaining. The last digit just goes off, right, when we divide by 2. So now I again see the last digit is 1. So again I add 1 to my answer, and then I divide by 2. So the last digit goes off. Now I see 0. So the remainder for the last digit is going to be 0. So I don't add it. This bit is not set, right? So this will be 0. Now I again divide by 2. I have this number 1 remaining. So I see that this is 1. So I again add 1 according to this line, and then I divide by 0. When I divide by 0, this time the number becomes 0, and then we can exit from the loop. So the output of this finally will be 3. So the number of bits which are set in b is equal to 3. Now this is the same number of bits which we have to set in x. So how do we do that? So first of all, it's very simple. First of all, we have to set same bits as a, okay, so that whenever we do XOR, when we do x XOR a, we are going to get 0, which is going to be the minimum possible. So our approach is very simple. Just see if the bit is set in a and set the same number of same place bit in x, so that if you do XOR of x and a, you get 0. Okay, because XOR operator, whenever, what is XOR? So XOR, whenever you have same bit set, for example 1, XOR 1 will give you 0, which is what we want. Okay, so wherever the bit is set in a, we will also set that bit in x. This is our simple logic, right? So let us do that. So let us start from the rightmost value. We discussed what we are going to do. We are going to always set the bit from the rightmost value, because we want to make the XOR as minimum as possible. So if we set from the rightmost value, we'll get a better answer. Okay, so I'm assuming it's a 32-bit number, so I'm starting from the rightmost value. And what I'm going to do, first of all, I'm going to find if the bit is set in a or not. If it is set in a, I'm going to set the same bit in x. How will I find if the bit is set in a? Very simple. Just what I'm going to do, so let me try to explain what I've done here. What is our a? Let's take an example. A is equal to 9. For example, a is equal to 9. So what is the binary representation of a? A will be 1001, right? This is 9. So what I am doing, I am finding out if this bit is set in a or not, right? So this is 32-bit number, so actually it will be represented like this. Okay, so this will be a, this will be the remaining 28 bits. Here we have 28 zeros, and then you have the last 4 digits like this. Okay, so for the first 28 zeros, we will just get 0. We will not get anything, right? So we don't write the complete binary representation. So let me just shorten it and write. So the binary representation is 1001, right? So what I'm going to do, I'm going to check first of all when my I value becomes equal to 3, right? When my I value becomes, this is the third digit from the rightmost side. So when I come to here, what I'm going to do, I'm checking if this bit is set in a or not. So here I'm taking a number 1 and I'm left shifting it by 3 times. When I do that, I will get this number, right? So this, what is this? This is 1 left shifted by 3 times. Okay, so this number, and what is this? This number is a. So what I'm doing, I am taking the AND of both of these numbers, a and 1 left shifted by 3 times. This is what I'm doing in my code. Why I'm doing this? Because I want to find if this bit is set in a or not. Now when I do AND, this will give me a non-zero value, because AND always returns a non-zero value when you have 1 and 1, right? The AND of 1 and 1 is going to return a non-zero value. So what is going to be the output if I do the AND of these two? Here I'm doing the AND of these two, right? What is going to be the output? The output is going to be some non-zero value like this. This is going to be the output, right? So when this is a non-zero value, that means the bit is going to be set. If here, let's consider the next case. If this bit was not set in a, right? If this was 0, then when you do the AND with such a number, then in this case you would have got the total output as 0. So whenever we want to check whether a bit is set in a or not, just find out if the AND of these two numbers are going to give you a 0 or a non-zero value. So here it's going to give us a non-zero value, right? So that means that this bit is set in a. Bit is set in a. If the bit is set in a, what you're going to do? Set it in x also. Set it in x also. Okay, so this is a simple logic. So how I'm going to set the bit in x? I will have to take an answer variable which I'm going to return, right? So initially let my answer be 0. So how to set a bit? Setting a bit is very easy. Just go to that value, go to that place where we have to set the bit, right? So what I did, let me explain what I did in this line. So my answer is initially 0. Okay, what is my a? Let me write it again. My a is 1001. Okay, and what is my 1 left shifted by 3 times? This is 1 left shifted by 3 times. This is a. Okay, so what I did, I found out that this bit is set in a, right? The third bit is set in a. So I'm going to go and set it in answer also. So I'm going to the value 1 left shifted by I is 3, 1 left shifted 3 times. I'm going to go to this value and I'm going to do OR with my answer. So this is my answer. So if I do OR here also, I'm going to get 1. So this is how I can set the bit in answer also. Okay, so if this is confusing, just see the video how to set bit in any given number. So now my answer becomes equal to this value. Okay, so that's it. Once this happens, I can decrease the number of, okay, let me take number of bits to set in x. Okay, number of bits to set in x, this is a variable. How many bits should I set in x? The same number of bits that are there in b. Okay, so now when this happens, I can decrease the number of bits to set in x, because I have already set one bit, right? So I have to set 3 bits, for example, in x. When I set a bit, I can decrease this count, and now I have only 2 bits to set in x, right? So next time this loop is going to run, after this complete loop runs, what will become my answer? My answer which I'm going to return, okay, this will become same as a, right? So wherever a had the bit set, so a was 1001, a was 1001, our answer is nothing but x, right? Answer is nothing but x. That will also become equal to 1001. So wherever I have the bit set in a, that bit I have set in x also. But what is the problem? The problem with this approach is I have to set 3 bits in x, but I have set only 2 bits in x, right? I have set only 2 bits in x till now, but I have to set 3 bits in x. Why I have to set 3 bits in x? Because there were 3 bits in b, right? We have already calculated that there were 3 bits in b, because of which we have to set same number of bits in x according to the question. But till now we have set only 2 bits. So where will you set the remaining bit? As discussed in the logic, now we want to set the remaining bit from the leftmost value. We will start traversing x and we will set the remaining bit here, so that we get the minimum possible value. So I have to, currently the third bit is not set, I have to set it. So what I'm going to do now, I'm going to traverse from the left to right. Okay, so I'm going to traverse from left to right, and what I'm going to do, I'm going to check if the bit is not set in answer from the left side, then I'm going to set the bit. Okay, that's it. This is the simple possible logic. So that's it. Here I can just give this piece of code. Okay, so if this, so what I did here, okay, let me just explain what I did here. So here, okay, this is our answer, right? This is our answer. Let me write it below. This is our answer, or x, in which 2 bits are set. How many bits are remaining to set? Okay, remaining number of bits, which is number of bits set in x, is currently 1, right? Because we have set 2 bits, only 1 bit is remaining to set. So what I'm doing, I'm traversing from the leftmost side. First I check this bit. This bit is already set, so I cannot set it, right? So I'm checking here whether the bit is set or not. How I'm checking? I'm checking if the bit is set. If the bit is already set, then this, as discussed in logic, if this bit is already set, this will give you a non-zero value. If it is not set, then it will give a 0 value. So for the last digit, it will give a non-zero value. This condition will not be true. But for the second last digit, this condition will be true. We will get a 0 here, because the bit is not set, right? So what we will do, we will go to that place and we are going to set that bit. And once we do this, we can decrease the number of bits set, and after this it will become equal to 0. So we can return the answer. We have set 3 bits in x, and this will be our final answer which we are going to return. This will be the answer for this test case. Now there's one more thing. Now when number of bits set becomes equal to 0, you can stop the iteration. So I will have to give this condition here, and I will have to give the same condition here. Okay, that's it. This is the simple logic, and let's run and see if it is going to work. So it's fine. Let's just submit and see if this is working for all the given test cases. So there is some error. Let us see what is the error. Okay, here, 1 second, I have to just make this a little bit proper. This should be fine now. Let me run and see if it is fine. Yeah, it's fine now. Okay, thank you for being patient.